Okay, so I think maybe some technical issues were there. So we saw why we implementing smart grid. So what is the advantages of smart grid over normal grid is reliability, second is efficiency, third is cost efficient, and fourth is what? Consumer reliability, or you can say you can give the supply of as per their choice. You can give the choice to consumers which kind of supply they want to use. And in smart grid, latest technologies are maybe you can see on Google's like electricity can be transmitted in future through satellites without transmission lines. Okay, from one point to second point to signals itself. Ma'am, next slide. So what is smart grid? In short, itself is like smart grid is IT plus electric grid. And IT, you can say like in the programming language. Okay, whatever the control system, control language is coming in electrical system, we can convert it into mathematical modeling and all such stuff. Plus electric grid already existing. So you can see in the diagram at left side supply and demand control. Okay, thermoelectric generation, pumped storage, hydroelectric system, whatever the generating plants are there, storage devices for the power system. Okay, tell me, what is the storage devices for power system? Battery, anything else? You can store power. Okay, in battery, which form of the energy is stored? Answer. After that, I will see that large scale photovoltaic generation system. Okay, solar voltage regulation equipment. Voltage regulation equipments are what? Voltage regulation equipments are what? How you can regulate the voltage? Anyone? Switch with integrated voltage current measurement sensor. Okay, I will tell with myself that voltage can be controlled with capacitor. Okay, capacitor bank. Okay, capacitor bank. Also converters. Which type of converters? Rectifiers, inverter. Rectifier, AC to DC, inverter, DC to AC. Okay. So then concentrator, smart electronic meter. Okay, a smart grid. Whatever the changes we are doing in control panels, we are making it in IT, in programming language, and electronic meter at applications side. Whatever the meters are coming is like kind of electronic. Okay, so consumer. So it is becoming like smart. Okay, we can call it as smart. So in generating side, you can make your generating station smart. How it is, you can use the programming language in control panels. Okay, like PLC, SCADA, whatever it is in electrical systems. In transmission, you can use converters, HVDC transmission. Okay, in distribution side, what is smart? Your energy meters, whatever you are using at homes or wherever your tariff or bills comes through that energy meter, how much is used. Okay, so it will be becoming in electronic form. Now itself, whichever, I think already it is replaced with electronic meters, electrical meters. Okay, electrical energy. Okay, anyone can tell me what kind of energy meter we use? So it is 2 watt meter. Okay, keep in mind. Ma'am, next slide. So short answer was IT plus electric grid. IT, as I told you before, programming language. Okay, computer science. In electrical, what is IT? In programming language, or we can say coding language, in electrical comes under PLC and SCADA. Okay, PLC and SCADA, keep in mind. In electrical applications, IT comes in which form? PLC and SCADA. What is long form of PLC and SCADA? Next lecture, you have to tell me what is the long form of PLC and SCADA. Okay, so you can see market and operation, generation, transmission, distribution, consumption, one way flow of electricity. So what is again advantage of smart grid is centralized and bulk generation, heavy reliance on coal and oil, limited automation, limited situational awareness, consumer lack data to manage. So this is telling the limitation of existing grid. Okay, like heavy reliance, limited automation, limited situational awareness, or consumer lack data. Okay, so that this is last point is very essential as an electrical engineer, that consumers don't know how the bills are coming and what. Okay, even electrical engineer itself don't know after getting degrees the what is the bill, how to read that bill. Okay, so you should know that. Ma'am, next slide. So what is future of electrical engineering or smart grid? Grid itself is electrical engineering. As electrical engineer, it is like market and operation, generation, transmission. The market and operation should be come at the distribution side itself. I think generation, yeah, control system will come here. Okay, in control systems, PLC and SCADA specific. Keep in mind, smart will be what is making PLC and SCADA. In that PLC, SCADA will take over PLC. Okay, and in transmission, as I told, what the smart things will come? Converters in the form of like what we call AC to DC rectifier, converter, and DC to AC inverter. Okay, this that will make our transmission system smart. In distribution side, energy meters or Wi-Fi and all kind of things. Okay, and consumption, two-way flow of electricity and information. Okay, so at existing grid at present only one way of electricity is coming. Okay, from generating side to distribution, but in smart it can be a two-way. From distribution side also you can take the electricity two-way. Okay, you can make it. Yeah, you can make it whenever like projects. Whenever the electricity is going in the form of the waste, you can store it and use it in smart way. You can do anything can be possible to interconnect the wastage of the electricity to use it, reuse it. Okay, so you can see from here the diagram itself shows towers, signals, satellites, electric vehicle. All these things comes under smart grid. Okay, next, ma'am. So in last slide, what we saw, first advantage of smart grid is what? Two-way electricity. Okay, two-way. So two-way you can do it. From distribution side also you can send the electricity. In smart, it is possible. So smart is what? Generation, transmission, distribution, consumer participation. Three: generation, transmission, distribution already existing in grid itself, but what is making is smart is like consumer participation. You are making consumer aware about their electricity. Okay, how electricity is coming. Also, maybe consumer will know in from which generation station it is coming. Okay, in future they know everything, what is the losses, everything, much as a electrical engineer. Okay, even they are not getting degree, but they will know about their electricity totally. So next thing is operations, market, service provider. Okay, and overall objective of smart grid is what? Smart or best or optimal utilization of all the available resources. And why we require all this optimal utilization? To make electricity as much as cost efficient. Okay, at the end everything comes up to cost. Okay, whatever application you are coming at smart grid, or whatever electrical application, electrical vehicle, whatever it is comes under grid, it must be cost efficient, not only operational efficient. Okay, cost efficient. Thank you, ma'am. Next slide. So definition by National Institute of Standards and Technology, NIST USA. Okay, so there are much more standards. You should know the standards in electrical engineering. Okay, this is one of the standard, National Institute of Standards and Technology. In measurement, there are ASTM, IEC. Okay, so what it gives as a definition of smart grid, I will read it. A modernized grid that enables bidirectional flow. As we saw, existing is unidirectional. Bidirectional means two-way. Okay, word itself is saying bidirectional. Okay, directional. Unidirectional means one way. Two-way, like a road. In roads we can say that one way and two-way. Now two-way is what? Bidirectional. Okay, flow of energy and uses two-way communication and control capabilities that will lead to an arrow app, new functionalities and application. Okay, so what making grid smart? Bidirectional. Second, communication system, control capabilities. In control capabilities, PLC, SCADA and converters, and array or programming, whatever it comes. Okay, and IEEE gives definition of smart grid as a system of systems where each functional domain consists of three layers. Okay, the power and energy layer, the communication layer. Okay, so power and energy level layer will become at the generation or distribution, transmission, whatever the core electrical. Okay, so communication layer will come under smart. Okay, the word smart will include communication and IT computer layer. In communication layer, you can work on the even the fault detections, IT computer layers, like whatever projects you can do it. And layer 2 and 3, okay, as I talk about the enabling infrastructure that makes the existing power and energy infrastructure smarter. Okay, so existing grid itself containing power and energy layer. Okay, so what makes it smart is like communication layer and IT or computer layer. Okay, in communication layer I told you PLC, SCADA, and IT computer layer is programming languages. You can use it like Wi-Fi, whatever, as a consumer side, electronic meters and all. Next one. So again, how many definition of one smart grid is like, you can see much more uh, societies have their own definitions. You can see European technology platform says a smart grid is an electrical network that can intelligently integrate the actions of all users connected to it. So what is like generator, consumer, and those that do both in order to efficiently deliver sustainable, economic, and secure electricity supplies. Okay. So sustainable word itself says like continuous supply. Okay. There should not be like what we call load shedding and all. Nowadays it is not there, but in previous day it was like terms like load shedding, blackouts. So sustainable is like electricity should be there always available. Economic, cost efficient. Charges should be as much as possible low. Okay, because consumers will be get attracted towards electricity or smart grid when you can give them as an advantage in the form of the cost. Okay, they don't want to listen your operational capabilities like sustainability, efficiency, and all converting and all like stuffs. If you tell them in the form of cost, they will get attracted, market will get attracted. And secure electricity supplies. Okay, security comes for the electrical engineers, whatever the operational manpower is there, for them it is important. Okay, in smarter grid, the opportunity, the smart grid is defined as, okay, whatever it is, a smart grid uses sensing, embedded processing, and digital communication to enable the electricity grid to the observable, automated, controllable, fully integrated. Okay, so we have to go with these words. Okay, controllable. It comes under control system, controllable and observable. Okay, this is very basic. What is controllable? Like able to manipulate the optimized. Optimized word is used to get exact, efficient. Optimize in Marathi, what we call minimum, like cost efficient. We call it as shortcut. Optimized way is shortcut. You can call it. We are taking a shortcut to reach the destination. Optimized way or optimized things. It gives exact whatever you want. As human mind, we always require a shortcuts. So controllable, able to manipulate, optimize. First is observable, able to measure and visualize. So you can make it like observable in the form of uh, fault detection, controllable in the form of SCADA and PLC, and automated also comes under PLC, SCADA, or language. Able to adapt and self-heal. What is meaning of adapt and self-heal? Whenever there will be fault, it should be automated. Even manpower is not there attending the fault. The system should clear the fault and make the electricity supply continuous as much as possible. Fully integrated. What is meaning of integrated? The integration itself, I told you in, I think, offline class at that day. Integration is like collecting the things. So we have to be integrate generation, transmission, distribution, and consumer totally. Not like nowadays we talk in the form of Genco, Transco. So we have to integrate all the things that will make the whole grid smart. Okay, fully interoperable with the existing systems with the capability to the incorporate diverse set of energy sources. Okay, so integrated, observable, controllable, and automated. These four words also describe the smart grid over the grid. Next slide. Okay, one more department is there, US Department of Energy. It tells a smart grid uses digital technology. What is analog and digital? Digital 1 and 0. Keep in mind binary. What whenever there comes is a 1 and 0 form of language, it is digital. Okay, in short way. It is not exact definition of digital, but as a electrical engineer, okay. So digital technology to improve reliability, security, and efficiency. Reliability word already we came through. Security, I told you, manpower. Efficiency, output divided by input power, both economic and energy of electrical system from large generation through the delivery systems to electricity consumer and growing number of distribution, generation, and storage resources. Okay, so you can see one more definition, like it is giving words reliability, security, efficiency. Okay, next slide, man. So there are various definitions of smart grid. Okay, but you should know these words like controllability, observability, automation, reliability, security, efficiency, all these things. Next slide, ma'am. Hello. Next slide, ma'am. Just a minute, I am getting call. Hello. मी क्लास घेतोय. काय नको काय नको.
Which slide, sir? This is next slide, sir. Okay, because of some problem, Aniket sir is not able to continue for next explanation. So we will stop here for the today. All present boys are requested to report electrical machine 1 lab for collecting their stationery. Okay, so we will stop here. Thank you for joining the session. First of all, boys report here electrical machine 1 lab for collecting their stationery.